This survey paper explores the development of meta-thinking capabilities in large language models, or LLMs, through the perspective of multi-agent reinforcement learning, or MARL. Meta-thinking refers to the ability for self-reflection, assessment, and control of one's own thinking processes, which is crucial for making LLMs more reliable, flexible, and effective, especially in complex or high-stakes tasks. The authors, including Ihsan Bilal from the University of Oklahoma, Muhammad Ahmed Mohsen and Muhammad Umar from Stanford University, Muhammad Awais Khan Bangish from Oklahoma State University, and Muhammad Ali Jamshed from the University of Glasgow, begin by highlighting the limitations of current LLMs. For instance, LLMs often generate hallucinations, which are incorrect or fabricated information presented as fact, and they lack built-in mechanisms for internal self-assessment. This means they don't naturally question or verify their own outputs, leading to potential errors in real-world applications. To address these issues, the paper discusses newer methods that have been developed. One is reinforcement learning from human feedback, or RLHF, where humans provide feedback to train the model, helping it learn from corrections. However, RLHF can be time-consuming and subjective, as it depends on human input, which might not always be consistent or scalable. Another method is self-distillation, where a model improves itself by learning from its own previous outputs, but this can reinforce existing biases or errors if not managed carefully. Then there's chain-of-thought prompting, a technique that encourages LLMs to break down problems into step-by-step reasoning. For example, in tasks like math problems, this method helps the model articulate its logic explicitly, leading to better accuracy. Yet, as noted in a meta-analysis, chain-of-thought prompting works well for structured tasks involving logic or mathematics but offers little benefit in less structured areas, like creative writing or everyday conversations. The core of the survey focuses on how multi-agent architectures in MARL can mimic human-like introspective behavior and boost LLM robustness. In these setups, multiple agents interact within a system, each with its own role. For instance, supervisor-agent hierarchies involve a higher-level agent overseeing and coordinating lower-level ones, much like a manager directing a team. This allows for meta-thinking by having the supervisor assess the outputs of other agents and make adjustments. Agent debates simulate discussions where different agents argue perspectives, helping to refine ideas and reduce errors through conflict resolution. Theory of mind frameworks go further, enabling agents to predict and understand the mental states of other agents, which is akin to human empathy and foresight in social interactions. By drawing from MARL principles, the paper explains how reward mechanisms can encourage meta-thinking. In MARL, agents learn through rewards and penalties, so meta-rewards could be designed to value self-reflection and accurate self-assessment. For example, an agent might receive a reward for identifying and correcting its own mistakes. Self-play, where agents compete or collaborate against versions of themselves, promotes continuous learning and adaptation, making LLMs more dynamic over time. The survey provides a comprehensive roadmap for building LLMs that are introspective, adaptive, and trustworthy, emphasizing how these MARL techniques can integrate with existing LLM frameworks. Moving on, the paper covers evaluation metrics and datasets essential for testing these enhanced LLMs. Metrics might include accuracy in self-assessment, reduction in hallucinations, or improvements in task performance under uncertainty. Datasets could involve simulated multi-agent environments or real-world benchmarks that require reasoning and reflection. The authors also discuss future research avenues, such as drawing inspiration from neuroscience to create architectures that better mimic human brain functions for meta-thinking. Additionally, hybrid symbolic MARL systems are proposed, combining symbolic reasoning, think rule-based logic, with MARL's learning capabilities to handle more abstract or ethical decision-making. Throughout the paper, key concepts like theory of mind, or TOM, are emphasized as vital for LLMs to anticipate the intentions of other agents or users, enhancing their social intelligence. The introduction ties this back to human cognition, noting how intelligence supports structured problem-solving while creativity drives innovation. For LLMs, enabling meta-thinking through MARL could bridge these aspects, allowing models to handle complex tasks by integrating logical reasoning with adaptive, creative responses. The paper references examples from models like GPT-3, Llama, and PaLM, showing how they already encode elements of human reasoning from their training data. By leveraging text-based thought generation, LLMs can be prompted to reflect internally before responding, but MARL adds a layer of multi-agent interaction to make this process more robust. Overall, this approach aims to evolve LLMs into more autonomous and reliable systems, capable of self-improvement in dynamic environments. In terms of index terms, the paper categorizes its content under topics like large language models, meta-thinking, multi-agent reinforcement learning, theory of mind, self-reflection, RLHF, supervisor-agent architectures, introspective AI, meta-rewards, and symbolic MARL hybrid systems. These elements collectively outline a path toward more advanced, human-like AI that can think about its own thinking, paving the way for innovations in fields from education to problem-solving.